So let's start the session. So it is week 8 of physical chemical processes for wastewater treatment. This is offered by NPTEL by Professor V.C. Srivastava from IIT Roorkee, and I am the TA for this course. I am Vaibhav Kabadwal, a PhD scholar from IIT Madras, the Department of Civil Engineering, and my discipline is environmental engineering. So this is a lecture outline. We will study few problems on adsorption, one problem on actually adsorption, and we will study about ion exchange after that. Is it what? So let's see some problems related to adsorption. Here is one problem. So the problem is like that: 100 ml of 600 milligram per liter of pollutant is placed in each pipe container with different amount of activated carbon. So we have taken 5 containers like this with different amount of. So what we are doing, we are changing activated carbon concentration, and we are shaking it for 48 hours. Then samples are shaken and filtered and concentration of pollutant measured. Then after 48 hours, the adsorption will happen, and whatever is not adsorbed, we are measuring the concentration of that after filtering out. Yielding the following analysis. Determine Freundlich isotherm equation. So we need to determine Freundlich isotherm equation from this data which is given here. So these are the 5 experiments for different conical flasks. These are the 5 different experiments, and the different carbon uh, by changing the activated carbon, we are doing experiments. So these are the different activated carbon concentrations, and after 48 hours, as written here, after 48 hours, we are getting this much concentration. So let's study a little bit about revise about adsorption isotherm. So isotherms are nothing but these are the plots of QE versus C. So if we plot, this can be 1 by E by 1 by C, log QE versus log C, and it can be any other form. So for here we will calculate Freundlich isotherm. For Freundlich isotherm, the equation is QE equals to Kf C to the power 1 by N. This is the equation for Freundlich isotherm. So as we can see, n can take any form here, any number. So this equation will be non-linear. So in order to linearize it, what we will do, we will take log on both the sides. So this is the QE is equals to KF C to the power and fact, yeah. And here CE is the concentration observed at the end of the test in our case according to the problem. And QE is the amount of pollutant adsorbed in milligram per amount of pollutant adsorbed uh, in amount of ad adsorbate provided or present. So it will be in gram. So we can say like for 1 gram of adsorbate, in 1 gram of adsorbate, how much pollutant is getting adsorbed at equilibrium. So this is QE. Now we will understand about Friendlich isotherm. So we have the equation in this QE is equals to KF C to the power 1 by N. So what we'll do, we'll take log on both sides. So it will be log QE and log KF. So F denotes here Friendlich. Yes. So this will be y is equals to c plus mx. This equation will be in this form. So here what we can do, we can plot this thing into a graph. So if you plot this, So if we can see, it will be log QE is equals to log K plus 1 by n log C. Here is y, here is x. So it will be log QE. So the equation will be like this. It has intercept on y. So if x equals to 0, then it will be C. And here the slope will be 1 by n. Slope is 1 by n. Intercept is C. That is C, sorry, it is C here. C is log here. Let me write it. C is nothing but log here. So these are now let's proceed with our question. The question was related to friend-rich isotope. So we have taken five flasks, five different containers we have taken, then we have added different activated carbon concentration, and then we shaken it for 48 hours, and after 48 hours we check the effluent concentration, which is not adsorbed over the adsorbent surface, and this is that concentration after 48 hours. And so we are asked in this question to plot the Friendly's isotherm equation. So for that, CE data is given to us, and QE we need to calculate. So formula for QE is QE can be calculated with the help of mass balance water. Formula for QE. QE is given as milligram of adsorbate per gram of adsorbent. Let's assume take X gram of adsorbent utilized, or we can say used. Initial concentration, you notice initial concentration, and C is effluent concentration. Effluent concentration means the concentration after the test, and V is volume of container or glass. So V is the volume of container or glass, and this will be in milligram per liter. C naught and C volume will be, we can say it will be in liters, because it is in milligram per liter. And what we can do, so the Q is the milligram of adsorbate, adsorb on adsorbent surface. Adsorbent surface, milligram of adsorbent surface per gram of adsorbent used for the test. So here what QE can be written as C naught minus C amount of pollutant adsorbed. C naught minus C is milligram per liter into V divided by X. This is the adsorbed per gram of adsorbent used. So this will be the formula for QE. So like for first trial, let's see how we can calculate it. So we have volume is 100 ml. See, these two things are same. Don't be confused with this thing. 600 milligram of pollutant. So initial concentration of pollutant is also 600 milligram per liter, and initial concentration of carbon is also 600 milligram per liter. So the carbon means adsorbent and adsorbate. Initially both are taken same here. So don't be confused with this thing. Volume is 100 ml, so volume will be 100 ml divided by 1000 ml per liter. So it will be zero point 0.1 liter. Volume is this much. So the initial concentration volume is zero point 0.1. So initial concentration is C naught is they have already given us C naught is 600 milligram per liter. And what else is required? So these are the different values of X. These are the different values of C. Correct? So we have X. Let's take for one. X is 600, X1 and C1 is 25. 600, 25, that's right. So X1 is given as 600, it was milligram. X1 is adsorbent mass. It should be in grams, so we'll convert it into grams. Milligram, 1000 milligram per gram, so it will be 0.6. So X will be 0.6 grams. Then we have been given C naught is 600 milligram per liter and C was C1. So we'll consider that X1 for first set of the test. C1 was 25. So formula of QE will be QE is V by X C naught minus C. So I will calculate QE1. QE1 will be 600. V is 0.1. X is how much? X is 0.6 and C naught is 600 minus d5. So it will be 1 by 6 of 578. To calculate it, how much we will get? 95.83. So the unit of QE is milligram per gram. Likewise, we will calculate QE2 also. So it will be the volume will be same. So the formula will vary like V by X1 C naught minus CE1. So for QE2 will be X2 will change and C naught minus CE2. Likewise, you have to calculate QE2. So I have calculated here for different values. So like it was 95.833. I have calculated it. Units are in This is around the graph. So this is like Q1, this is Q2, this is Q3, Q4, Q5, QE1. You can say QE1, QE1, QE2, QE3, QE4, QE5. So this is the QE value. And then what we have to do? We know QE, we know CE. Accordingly, we'll take log of QE. So it is plotted between log QE and log CE. So we will take log of CE and then we will plot these values, and then we will find slope and intercept. So from this intercept we can find KF and N, and then you can put it in the original equation. So let's see this. So we have QE, so pollutant is called CE. This is CE. So now we will take log for this value, log of CE, log of QE, and then we will plot it. So these are the values with log. I have plotted these two equations, and then I got the equation. Maybe it is bit small. Now you might see y is equals to 0.18, y is equals to 0.1875 x plus 0.1875 x plus 1.71. That's enough. So intercept. What was the intercept for us? Intercept was log Kr. So it was intercept, and so we can calculate Kr is equals to 10 to the power 1.7. Let's calculate it. 51.28. Fifty-one point two eight six, and then we have slope here. Slope was 1 by n is equals to 1. N is equals to 1 by 0.1875. Is 5.33. Let's again check this. Y is equals to mx plus c. Actually, we can use this directly 1 by n as our in equation also. So our equation was which was QE is equals to KF 1 by N. So we can write it as QE is equals to KF was how much? KF was 51.286. QE is equals to KF C to the power 1 by N. KF was 51.286. So KF was 51.286 and C to the power 1 by N. 1 by N was 0.1875. So we got the value of QE. So now how can we use it? Let's see. So let's say this is the continuation from first question. So let's say we need to calculate amount of carbon required. Amount of carbon means activated carbon required if the C naught is given, that whatever it was given was 500 milligram per liter, and the effluent C will be 10 milligram per liter, and then discharge is 10,000 gallon per liter. Okay, so we need to calculate how much amount of carbon required in C naught is 600 milligram per liter, C is 10 milligram per liter, and discharge, this is discharge or flow rate, or flow rate is 10,000 gallon per liter. Now we will proceed also. We know the value of QE. We know the formula for QE is P by X C naught minus C. This is the one formula. And we also know one formula for QE is KF C to the power 1 by N. We know the volume from previous question. We can it was 0.1 ml, so it was 600. It, and KF is we know around 51, and N was 1 by N was 0.18, and C we know 10. So from this equation we can find X. X is the mass of adsorbent used in grams. We should know this thing in grams. So from here, if I calculate X, the equation will be C naught minus C Kf C to the power 1 by L. The volume was zero point 0.1, C naught was 600, minus what was C? C was 10, and then Kf was around 21 point. Let's take it as 3, 51.3, and take C as 10 to the power 0.187. So if you calculate X, how much will we get? So X will be 0.75 grams. I hope this answer is correct. So we calculated X, and then what else do we know? We know QE also. So let's approach this through another way also. So we will calculate this thing individually. We'll first write pollutant removed. How much pollutant is removed? 600 minus 10 gallon per day, gallon per liter, 10,000 gallon per day. Gallon per day. If I convert gallon to liter, it will be 3.78 liter into how much was it? Was the discharge? It was 10,000 liter per day. If you calculate this, how much will it come? So 1 gallon is equals to 3.78 liters. So it will come as, so the units are like milligram per liter, gallon per day, and liter per day. Will be this unit will be let me rewrite it. I did something wrong in this part. The pollutant removal is 600 minus 10 milligram per liter, and this is per liter, but we are given 10,000 gallon, 10,000 gallon per day. So in 1 gallon, there are 3.78 liters. So this will be the unit conversion. Liter will cancel in gallon. It is milligram per liter. So it will be, if we solve it, it will be 2230 milligram per day. So it will be 22.302 gram per day. Kilograms. Sorry. This much pollutant removed per day, and then we can calculate QE also. Fifty-one point 51.3 into 10 to the power 0.187. So 51.3 into 10 to the power. If you solve it, you will get it in milligram per gram. So further, if we solve it, we get it as, let's solve it, 51.3 into 10 to the power 0.187. This coming as 78.91. 78.91 milligram per gram. So we need to calculate how much carbon is required. So this is the carbon and this much is the pollutant. So we can divide what is the pollutant removal divided by, let's solve it through equations itself. So we have the value of QA, pollutant removed, divided by amount of adsorbent used. So if we write here as amount of adsorbent So we know QE is equals to amount of carbon, amount of pollutant, amount of pollutant removed, and amount of adsorbent used. Amount of pollutant removed. So amount of adsorbent used will be amount of pollutant removed divided by Okay, so we have both the values with us. These values are, there is an issue with this thing. Let me close it and open it again. We just have to do, just have to divide 22.302 into 20 6 divided by 78.91. Units are kg per day, milligram per gram. So ultimately you will get the answer 282.625 kg per day of acrylic carbon required. So this is very easy question. We can solve it with the help of unit solution. Now we will move on to ion exchange. So what is ion exchange process? We'll see. So ion exchange is the, close it and open it again. What is ion exchange process? The process where an insoluble substance removes ion from an electrolytic solution and releases other ions of like charge into the solution in a chemically equivalent amount. So what we can simply assume here, like in adsorption, there is some similarities and differences between ion exchange and adsorption process. So in adsorption, there is kind of the sites are there. So the particle will come inside, will go inside, and it will get adsorbed. But while in case of ion exchange, the ion will be replaced in the resin. Ion will be replaced in the resin. So how will it replace? Like it will be replaced in the chemically equivalent amount, and the same charges can be replaced. Suppose if it is cation exchange resin, it can exchange only cation based on some limitations or based on some requirement. And if suppose we have sodium in the resin, so it will replace It can, so sodium will be replaced by calcium. So resin will contain uh, calcium and sodium will be released in the effluent. So this is a kind of ion exchange process. What are the common application of ion exchange? So here we have for water treatment to soften the hard water, means to remove multivalent or polyvalent cations, and for municipal wastewater treatment to remove nitrogen and phosphorus. So it can remove nitrogen and phosphorus. And for industrial wastewater treatment to recover or remove many different ionic chemical species. So we can recover different metals also or ionic species. Number of exchange sites. So the number of exchange sites are finite or infinite. So in ion exchange we have finite exchange sites. Difference of one ion over another is often expressed in terms of separation factor. So the preference is expressed in terms of separation factor. So what is this separation factor? Let's understand this. So here, let's write the equation of ion exchange. So this is n moles of resins attached with n moles of resin attached with the cations A plus, and here the B n plus is in the solution. So here it is the resin, here it is in the solution, and the both will react. What will happen? Let's say condition is favorable and the Bn plus will replace A plus. So it will be Rn minus B plus Bn plus n moles of A will be released. So now this will be resin and this will be solution. So initially the B plus Bn plus was in the solution, but Bn plus, let's take an example of calcium 2 plus, it will be easy for all of us to understand. Initially the calcium is, we know the calcium imparts hardness. The calcium was in the solution, we pass it through the ion exchange reagent, it replaced sodium and uh, the the calcium will be in the resin and n moles of sodium came out of the ion exchange process. So let's, if I want to now write it, how can I write? Na plus plus Ca2 plus capital R2 Ca2 plus 2Na plus. So here I can write 2. Now the equation is balanced. So for this, what is the separation factor or selectivity quotient? So we can write the equation here. So the selectivity quotient or selectivity or separation factor is defined as Qs. Q subscript S. It is uh, one more thing is there, that is called selectivity coefficient. Now we are studying about quotient. So quotient will, the selectivity coefficient will be the equilibrium constant, but selectivity quotient will not include the powers. So it's simply, if I want to write, it will be Rn minus Bn plus. So this is the product which is in resin. This A plus is in the solution. Similarly, in the reactant side, R minus A plus is in the resin, and Bn plus is in the solution. So this is the, we know this is the product, this is the reactant. So what it tells, if QS is greater than 1, ion Bn plus is preferred over A plus. So if Q is greater than 1, then ion Bn plus is preferred over A plus. And if QS is less than 1, resin preferred ion A plus over Bn plus ion. If QS equals to 1, equal affinity for both ion. So this was about selectivity coefficient. So what are the steps of ion exchange? So these are the steps similar to the adsorption. So the bulk transport, these are the repeated things. So what will happen? So the ions, first ion will come, first the ion will come in, first the ion will come in contact with the external surface. External surface will have a film, so it will reaches near the film, so that is called bulk transport. So when it crosses the film, that is called film diffusion. So initially it was called bulk diffusion, it was called film diffusion. So the film on the surface of the resin, when it crosses, that is called film diffusion. Then core transport, core diffusion happens. So core diffusion means the ion which has to be removed, or which needs to exchange, it will come through the pores and it will get transported. So that is pore diffusion, and then actual exchange happens. And after the actual exchange happened, now same procedure will be followed for the uh, cation or anion which was present in the resin. So now it will come out through pore transport, same mechanism. Then through film it will cross, so that is film diffusion. And now it will cross the film which is around the resin, so which is called boundary layer also sometimes. So it will transfer through the boundary layer or the bulk. So this is called bulk diffusion. And these are the processes which happen in an ion exchange media. So the affinity of an ion for a resin depends on, so how the affinity depends? The affinity depends on the valency of the ion. What is the valency of ion? Suppose, uh, let's say iron 3 plus, it has more valency. So it will, it has, so the resin has more affinity towards more positive charge or more negative charge. So the charge here is absolute. So it has more affinity, it has less affinity, it has less affinity. Likewise for anions also, PO4 3 minus has more affinity than 2 than 1. So if higher valency, then higher preference, and if higher the degree of cross linkage, it may be too large. So if the linkage is very too large, then ion may be too large to penetrate. So then ion cannot exchange easily if the degree of cross linkage is too high. then it is difficult for the ion to penetrate. What is the total capacity of resin? So the total exchangeable ions per unit mass per unit volume of resin, or it is defined in two terms. One is equivalent per gram or equivalent per meter cube. Either we can say equivalent of equivalents replaced per unit gram, or we can say, like, suppose this is the resin, we can either say it is in kg, or we can say how much meter cube. So in this kg, how many equivalents of iron it can replace? This is called capacity, and that capacity is called resin capacity. Adsorption is used to remove. Now let's talk what to remove. No, this is the ion exchange we talked about what to remove. This is the different question. So what are the different types of, we discussed what to remove through ion exchange. Yeah, here we discuss what to remove. To soften the hard water like cation Ca2 plus, Mg2 plus, Al3 plus, and we can remove through ion exchange. Nitrogen and phosphorus can be removed, and in industrial wastewater treatment, we can remove and recover ions from ion exchange. So this was a redundant question. The preference of one ion over other is often expressed in terms of separation factor that we studied. What are the steps we studied? The affinity of resin depends on these factors we studied. What is the total capacity of resin that we studied? Equivalent per meter cube or equivalent per kg? What are different types of arrangement or of alternate arrangement? So what we can do there are three arrangements possible. One is standby column. So in a standby column, there are minimum two columns or two resins provided, so that if one will go for regeneration, if one goes for regeneration, then another can take care of it. And another thing is column in series. So when we provide more efficiency, then we provide them in series. And if we provide, so minimum number of units required for standby columns are two. One will be in service, one will be in standby. When columns in parallel are used, so when we need to treat large amount of wastewater, then we use parallel system. So that parallelly we can get high flow rate. But in a series system, uh, if we want higher good quality effluent, then we use series system. In this series system, what will happen? Initially, the first bed will be exhausted, so we will have some standby columns also. So we will remove this first, and then this will be exhausted. Then we will remove. Then we will remove this thing. Then we will remove this thing. Then we will remove this thing. So, which resin matrix is most widely used? So we use polystyrene divinyl benzene matrix. Polystyrene DVB matrix. So this matrix is used as a resin. Resin selection is primarily based on operating capacity. Resin selection is primarily based on operating capacity. The units are milliequivalent per milliliter per SCS. So why operating capacity is always there than advertised exchange capacity. So the operating capacity is less because of incomplete generation, because generation is not complete every time. and early leakage. So there can be breakthrough. So because of these two reasons, the capacity, the advertised exchange capacity is always less than the the operating capacity is always less than the advertised capacity. Does the flow rate through the column affect the kinetics of adsorption bed? Does the flow rate through the column affect the kinetics of adsorption bed? Yes, it affects. Let me check what is the issue. Yeah, we were studying about does the flow rate through the column affects the kinetics of adsorption bed? The flow rate, suppose the flow is happening through the resin, this flow rate, whether it is more or it is less, is affecting the kinetics of the adsorption bed. Yes, it affects. Yes. The reason is the longer the water is in contact with resin, the greater the opportunity for the mechanism of exchange process to come into play. So the more the contact time, more the removal can happen. So thus, the longer the contact time, the longer the time to reach the breakthrough. Why co-current beds are backwashed? So let's first understand what is co-current and what is counter-current. So in co-current, what happened? So for regeneration of bed, this is the uh, so let's say this is the bed. So this is the flow, and regeneration is also in the same direction. When flow and regeneration, generally the flow is downwards, and if flow and regeneration are in the same direction, we call it co-current. And when the flow is downward and regeneration is upward or in opposite direction, then it is called counter current. So the question is why co-current beds are backwashed. The reason is here to relieve the compression. First is to relieve the compression, and second to remove the particulate matter, often called fines. So what happens here? So there the particles are loose, but for regeneration we need to provide high means more quantity of water, so they will be compressed. In order to lose it, we, we backwash them, and secondly we can remove some particulate matters also, which are called fines. So that's why this thing. So that's why we backwash the ion exchange filters. Estimation of resin volume depends on the results of Resin volume, estimation of resin volume depends on the result of column studies. Perform column studies. The out of service time includes, so the out of service time is the time for which the the time for which the ion exchange column is not functional. So this is the ion exchange. This is called out of service time. So the time when it is not functional, it is called out of service. So this will include backwashing time. It will include time for regeneration. It will include time for rinse. So rinsing can be is provided in slow and fast way. Let's solve one question. A home water softener has zero point 0.1 meter cube of ion exchange resin. So it has zero point 0.1 meter cube of ion exchange resin with an exchange capacity of 57 kilogram per meter cube. So the capacity is 57 kg of hardness as CaCO3 per meter cube of resin volume. Correct. The capacity we studied. The occupants use 2000 liters of water per day. The water contains 20 milligram of hardness as CaCO3. It is desired to soften it to 85 milligram per liter as CaCO3. So we'll write some data. Ion exchange unit volume is 0.1 meter cube. And it has with ion exchange and resin and exchange capacity of 57 kg per meter cube. The occupants use 2000 liters of water per day. The occupants use of water is 2000 liters per day of water. And initial hardness is and initial hardness is 20 milligram per liter, but we have also told it is also told like the softener has 100% removal efficiency, means hardness removal efficiency. And other thing which is given is we need desired hardness is how much? 85 milligram per liter. It was 85 milligram per liter. Desired hardness was is 85 milligram per liter as severe CO3. The initial hardness was 280 milligram per liter, and final hardness required is 85 milligram per liter, and the removal efficiency is 100%. Means the ion exchange has 100% removal efficiency. So some part of this of water should be bypassed so that we can get the hardness of 85 milligram per liter, because for drinking water some part of hardness is required. So we need to find two things: how much water should be bypassed. Right. So how much water should be bypassed? That will uh, calculate through mass balance. So what we will do? So here is the ion exchange process. So what will happen here? The water is coming here as 2000 liter per day. X amount will go, X liter per day will go this way, and 2000 minus X liter per day will go through ion exchange. So it will have the concentration of 0 milligram per liter. It will have the concentration of 85 milligram per liter. This will be Q mix, that will be 2000 ohm. So we'll apply mass balance here. Apply mass balance at point A. So influent what? Influent hardness at A will be equal to applied hardness at A. So what will be the influent hardness? 2000 minus X into 0 milligram per liter plus X liter per day into it is not 85, it should be 285. x liter per day into 280 milligram per liter, and the desired hardness will be Qmax, Qmix. So Qmix will be 2000 into 85 milligram per liter. So this will be 0. So the x liter per day is equals to 2000 into 85. 85 divided by 280. 2000 into 85 divided by 20. So x will be 607.14 liter per day will be bypassed. So 607.14 liter per day to be bypassed. Second thing is how much time of generation, how much time between regeneration cycle or breakthrough time. So we'll copy this formula. Total capacity of resin is how much? Total capacity is 57 kg of hardness per meter cube. 58 total capacity. A home water softener has 0.1 meter cube of ion exchange resin with an exchange capacity of 57 kg per meter. Total capacity is 57 kg per meter cube of resin, and mass of ions removed per unit time. So mass of ions, how much mass, how much is the mass of ion removed per unit time? Mass of ions removed per unit time. This will be 280 minus 85 gram, or you can say milligram per liter into 2000 liter per day will be cancelled into 100 minus 6 kg per day. How much it would be? would be 0.39 kg per day. So total capacity of resin will be, let's say if it is A and if it is B, so the A part will be, total capacity of resin will be 57 kg per meter cube. So what is the volume of the resin we need to calculate? So it has volume of 0.1 meter cube. So A will be 57 into kg per meter cube into 0.1 meter cube. So it will come out as 5.7 meter cube. And for B, this much, 0.39 kg per day. So breakthrough time will be A divided by B. So it will come out as 5.7. No, unit will be, unit is wrong, something is wrong. Let me correct it. Total capacity of resin will be 57 kg per meter cube into 0.1 meter cube is the volume of the resin. So it will be 5.7 kgs. And B is 20 minus 85 into 2000 liter per day into 20 bar minus 6 kg, should be like kg per grams or milligram. Milligram and milligram will be cancelled, so it will be 0.39 kgs per day. So total exchange capacity will be 5. Total exchange capacity would be A by B. What is A? A is 5.7 kg and B was 0.39 kg per day. How much is the value? 14.615 days. This is the value of breakthrough time. So after this many days, the cation, the ion will, uh, after this many days of usage, we will get the breakthrough concentration. So what is breakthrough concentration? It will just, let's make a plot so that you can understand. So let's say this is C out by C, and this is the volume of x-axis. It is the volume of water or wastewater treated through resin. Initially, what happens? So if we are told it has 100% removal efficiency. So initially, for or we can say V is equals to Q into T. So if we multiply volume, or if for T is equals to how many days, whatever came out here for 14.615, if you multiply, V is equals to Q into T, like this. Whatever the Q I am considering, T is equals to 14.615. T is equals to 14.615. So after this volume, after this V dash, let's say, after this V dash volume, before V dash, the concentration will be zero because it has 100% efficiency. So now V dash, after V dash, the concentration will start increasing gradually. Suddenly, the it will sorry it the concentration will increase suddenly, and it will follow this pattern, and then it will reach C like this. It will reach when C in by C naught will be equal to 1. Will reach this level. So this will be 1 when C in will be equal to C out. Means there will be no treatment. There will be no treatment. There will be no treatment at this point, and a breakthrough. In general, the breakthrough is this point, but in books, the breakthrough is defined as either 5% or either or 10%. So the thing is that suppose we require some concentration limit, we need the effluent concentrations are not zero for the discharge. So what we do, suppose if calcium, suppose some element or ion has a discharge limit of X milligram per liter. So we consider breakthrough as 0.05 as this value, this concentration. So it is considered, so this percentage is considered as breakthrough, and this is considered as exhaustion. Exhaust. This is breakthrough. Thank you. So this was all about week 8 session. Thank you for joining.